Sample problem 9.03. In the given figure, the three particles are initially at rest. So we have to see the given figure. There are three particles mentioned here as a dot. So the first particle takes the value of 4 kilogram. The second one is 8 kilogram and third one is 4 kilogram. Initially, these three are at rest. Each experience an external force due to bodies outside the three particle system. So that means we applied some external force on these three particles. The directions are indicated and the magnitudes are F1 which is equal to 6 Newton, F2 which is equal to 12 Newton and F3 which is equal to 14 Newton. What is the acceleration of the center of mass of the system and what direction does it move? So we have to answer for two questions here. The first thing we have to find what is the center of mass for the acceleration, and the second one we have to find the answer for theta. The theta indicates the direction here. So let's see, better we can write the given first. What is given in the question? They give the magnitudes of three forces, which is F1 6 Newton and F2 12 Newton and F3 is 14 Newton. Now we have to consider the Newton's second law. What is Newton's second law? The net force, which is equal to mass multiplied by acceleration. So here acceleration, center of mass, we have to find. So here CM stands for center of mass. So how we can find the net force? We can find the net force is nothing but three forces acting on this object. You can see the three particles. F1 is an horizontal force which is acting in the negative direction of x. Likewise, your F3 is an horizontal force which is acting in the positive direction of x. But when you see the second particle, we applied F2 as an angled force with respect to 45 degree. So we have to write the net force F1 plus F2 plus F3, which is equal to mass multiplied by acceleration center of mass. Now we are going to find the center of mass for the acceleration. So therefore, the acceleration center of mass, which is equal to F1 plus F2 plus F3 divided by the total mass, because the total mass is nothing but here the caps M indicates M1 plus M2 plus M3. That is the answer for caps M. Clear? But here the most important thing, we cannot able to substitute the values directly because we have some x component and y component force. So what we have to do, first we have to find the acceleration center of mass for x component and acceleration center of mass for y component. So after that only we are going to find the magnitude. So for finding the acceleration center of mass for x component, which is given by the rule F1 of x plus F2 of x plus F3 of x divided by the total mass of the system, which is M1 plus M2 plus M3. And likewise, we have to find the y center of mass, acceleration center of mass for the y component. So the acceleration center of mass for the y component, which is F1y plus F2y plus F3y divided by the total mass, which is M1 plus M2 plus M3. Now we have to substitute the values. Let's see the figure. You can see F1 of x. Actually here F1 is the horizontal force, so which is exactly in the negative direction of x. So we can substitute the value, but this is the negative direction. So what we have to do, I have to substitute the value here as minus 6 Newton. Why? Because it is in the negative direction. The force is applied to the negative direction, and also the magnitude of the force is given here, F1, which is 6 Newtons, but this is minus 6 Newton. Why? Because the force acting in the negative direction. That's the reason I substitute the value of minus 6, and this is only for x component because this is a horizontal force. Likewise, for the F2x, we can see the second object, the second particles. We have two components. One is vertical component, which is F2 of x. This is F2 of y, and this will be f2 of x. That means the x component stands for cosine. So how we can write the magnitude of f2? They clearly mentioned in the question as 12 Newton, right? So the 12 Newton magnitude we applied. So how we can write the f2x? So 12 multiplied by cosine of theta. So what is the angle here? 45 degree. Plus your f3, again it's a horizontal, so no y component, so we have only x component, but this is in the positive direction, and also the magnitude of y3. So better we can see the value. F3 magnitude is 14 Newton. So how we can write the value here? So the force is acting in the positive direction of the x, so we have to write 14 Newton divided by m caps m, that is nothing but it's a combination of all masses. So we have to add all the masses, 4 kilogram plus 8 kilogram plus 4 kilogram, that is nothing but m. So, or I can write it here. Here m stands for m1 plus m2 plus m3. So I can just write here 4 plus 8 plus 4. So now we have to find the answer for the acceleration center of mass x component value. So let's see what is the answer. Minus 6 Newton plus 12 cosine of 45 degree plus 14 divided by 4 plus 8 plus 4. I got the answer here as 1.03. So what answer I got? 1.03, and unit is very, very important. The acceleration unit is meter per second square. So this is our x component of the acceleration center of mass. Likewise, we have to find the y component. So again, we have to see the graph to write the values here. What is the y component of f1? There is no y component because your f1 and f3 are horizontal force. There is no y component. So we have to substitute 0 for this because there is no y component. And here f2, there is y component, which is f2 of sine theta, right? So what is f2? f2 magnitude is 12 Newton. So 12 multiplied by sine of 45 degree. And likewise, f3 is a horizontal force. There is no y component, so we can put 0 here. So divided by 4 plus 8 plus 4. Let's see what is the answer for the acceleration center of mass for the y component. So here 12 multiplied by sine of 45 divided by 4 plus 8 plus 4. I got the answer here as 0.53. So 0.53, the unit is meter per second square. So once we find the value of the x component and y component for the acceleration center of mass, we can easily find its magnitude. So how to find the acceleration center of mass magnitude? As we already studied the explanation, we studied clearly in chapter number 3 vector for finding the magnitude. How we can write the acceleration center of mass, which is equal to the square root of the acceleration center of mass x component square plus the acceleration center of mass of y component square. So what is our x component of center of acceleration center of mass, which is 1.03 square plus our y component acceleration center of mass, which is 0.53. So 0.53 square. So now I'm going to find the answer. Let's see what will be the answer. 1.03 square plus 0.53 square. I got 1.16. So 1.16, and the unit is very, very important, meter per second square. So this is the acceleration center of mass. So this is the answer for the first question. And in the second question, they asked to find the direction. So for finding the direction, it's very easy because we already studied the formula in chapter number 3 vector. Theta, which is equal to tan inverse of the acceleration center of mass for the y component divided by the acceleration of the center of mass for the x component. So I have to substitute the value here. So therefore, tan inverse the acceleration center of mass y component is 0.53. So 0.53 divided by the x component of the acceleration center of mass is 1.03. So 1.03. Let's see what will be the answer. So theta, which is equal to tan inverse of 0.53 divided by 1.03, I got the answer here as 27.23. 27.23 degree. So this is the answer for the second question, which is nothing but the direction. That's it. Thank you.